In this video, we're going to use the definition of a derivative to find the derivative. Okay, so let's start with the definition. F prime of x equals f of x plus h minus f of x over h, the limit when h approaches 0. Now, most people get stuck on the first step, on what it means f of x plus h. Here, this is a composition of functions where you're going to substitute for every value of x, x plus h. Okay, so let's find the first one. So you have that f of x equals 2x minus 3. I want to find the derivative of f of x. So f prime of x equals the limit when h approaches 0 of f of x plus h. So I'm going to substitute x for x plus h. So this is going to be 2x plus h minus 3. Notice that wherever I saw an x in the function, I substitute for x plus h minus. Now the second step that is most common for errors is this step. So what I want you to do is to put a bracket or a big parentheses and then draw and write down the entire function. So 2x minus 3. Everything divided by h. So now we keep going. We distribute the 2, so you get 2x plus 2h minus 3. And then this minus is going to distribute on both. It's going to be negative 2x, and negative times negative is positive 3 over h. Now, how do I know that I'm doing it correctly? Well, if all terms that have no h cancel out, that means you're doing it correctly. So for example, 2x minus 2x is 0, negative 3 plus 3 is 0, so you're left with 2h over h. Notice that h over h is 1, given that h is not 0. So you're left with h approaches 0 of 2. This limit is just 2. So the derivative of f of x equals 2x minus 3 is just 2. Okay. Now, it says find the value of f prime of a. In this case, f prime of 0 is still 2 because there's nothing to substitute. And that will be your answer for this function. Now, if I were to jump straight to f prime of 0, and I don't want to find f prime of x, then we're going to use a different equation, okay, which is as follows. This one is f prime of a equals the limit when x approaches a of f of x minus f of a over x minus a. Okay, now don't confuse the limits and the definition. These are the same. This is going to give you the same value, but this one gives you the derivative at a point. This one gives you the derivative of in terms of x. So in this case, if I were to find still same one where a is 0, so f prime of 0 equals the limit when x approaches 0 of my function, which is 2x minus 3, minus f of 0, which is plugging 0 for x, so 2 times 0 minus 3, over x minus 0. We simplify that. You get 2x minus 3. 2 times 0 is 0. 0 minus 3 is negative 3. Negative times negative is positive 3 over x, which is x minus 0. Oh, I got myself confused. all good. We'll fix it. Here, x approaches 0. Negative 3 plus 3 is 0, so 2x over x. Again, what is that equal to? The limit when x approaches 0 of 2 is just 2. So again, notice we get the same answer. Now, we're going to do a different function. So let's do this one. So if f of x equals x squared minus x, x squared minus x, then you want to find the derivative when x equals, I think it's 1. Yep, 1. Well, again, we can do it both ways. We can find the derivative in terms of x and then plug in 1, or you can use the second definition and go straight to the value. So I'm going to do both. So again, f prime of x is the limit when h approaches 0 of f of x plus h minus f of x over h, okay, which is the limit when h approaches 0. Now again, for every value of x, I'm going to substitute x plus h. So it's going to be x plus h squared minus parentheses x plus h minus. And again, don't forget the big bracket in this step. I'm going to write everything that is f of x, so in this case x squared minus x over h. Okay? So this becomes the limit when h approaches 0. Notice that x plus h squared, you get a FOIL. So that means multiply it twice. The negative here distributes, so negative x minus h. And the negative here also distributes, so minus x squared plus x over h. Let's go this direction. Right? We FOIL, so x squared times x times h, xh, h times x, xh, and then h times h squared. Okay, minus x minus h minus x squared plus x over h. Now again, the rule is, in order for this to be correct, all terms that have no h has to cancel out. X squared minus x squared is 0. Negative x plus x is also 0. So you're left with x plus h, which is 2xh, and then minus h over h. Now, this is just a regular limit problem. Here, in order to get rid of the 0 over 0, we factor the h. So h times 2x minus 1 over h. We get rid of the h's. So you're left with 2x minus 1. The limit when h approaches 0 of 2x minus 1 is just 2x minus 1. Okay. Therefore, the derivative of f prime of x is 2x minus 1. So if I want to evaluate it at 1, you plug in 1 for x, and you get 2 times 1 minus 1, which is 2 minus 1, which is 1. Okay. Give me 1 second. My little kitty cat is crying because she wants to go inside the room. 1 second. Alright, I'm back. So that's how you will find f prime of 1. You just plug in 1. If you wanted to find it directly, let's say you don't want to know what f prime of x is, you just want to know what f prime of 1 is. And you plug it into the second equation. So let's change my colors here. So f prime of 1 equals the limit when x approaches 1 of f of x minus f of 1 over x minus 1. Okay, so x approaches 1. F of x is just, what is that? It's going to be x squared minus x minus f of 1, which is 1 squared minus 1 over x minus 1. So it's going to be x squared minus x. 1 minus 1 is 0, so it's just that. Okay. And in order to solve this limit problem, you factorize the x. You get x minus 1. Okay. So the limit when x approaches 1, the x minus 1s cancel, and then the limit when x approaches 1 of x is just 1, which is exactly the same thing. Okay? It's just a different way to solve the same problem. Alright, so now let's look at my next function. So my next function is going to be the square root of 2x. Okay, so again, if f of x equals the square root of 2x plus 1, let me double check that. Yeah, and then you want a equals to 4. So first I'm going to find f prime of x. So remember, it's the limit when h approaches 0 of f of x plus h minus f of x over h. Now again, the two common mistakes is this one, f of x plus h, and the minus not being distributed. So wherever you see x on your function, you're going to substitute for x plus h. So it's going to be 2 times x plus h plus 1 minus square root of 2x plus 1 over h. Now, this one is a tricky problem, right? Because it's not obvious what to do immediately. But if you've been taking my class, you already know that from here, in order to find the limit, you have to multiply by the conjugate. In this case, 2x plus 2h plus 1 plus 2x plus 1 on top and bottom. So 2x plus 2h plus 1 plus 2x plus 1. Okay. Now, the bottom one, you will not distribute the h. Okay. And you should know by now, if you've been watching my videos, that the reason we multiply with the conjugate is to get rid of the middle terms. So you're going to have this squared minus this squared. It's going to be 2x plus 2h plus 1 minus 2x plus 1. Okay? If you don't believe me, just do the foiling between this. So this times this, this times this, this times this, and then this times this. And then on the bottom, you just leave it alone. So square root of 2x plus 2h plus 1 plus 2x plus 1. Now again, this minus is going to distribute between both. So you're going to have two, oops, let me put the limit first. So the limit when h approaches 0 of 2x plus 2h plus 1 minus 2x minus 1. And again, the bottom stays exactly the same. Nothing changes yet. Oh, that's not a 1. That's not an h, that's a 1. Okay. Now notice again, the terms that have no x have to be canceled. So 2x minus 2x is 0, 1 minus 1 is 0. So you're left with the limit when h approaches 0 of 2h over h square root of 2x plus 2h plus 1, and then plus square root of 2x plus 1. Okay? Again, the h's cancel. You're left with this. So now that you got rid of the h's, now you can plug in the limit. Okay? And the reason you can do that is because you won't have 0 over 0 anymore. So now that you're plugging the limit, you can get rid of the limit. Okay, so we're going to plug in h, 0 for h. So we're going to have 2 square root of 2x plus 1, and plus square root of 2x plus 1, which added together is going to give you 2 square root of 2x plus 1, 2's cancel, 1 over 2x plus 1. So that's your derivative. Okay, so f prime of x is 1 over radical 2x plus 1. Now if I want to plug in 4, so f prime of 4 is 1 over radical of 2 times 4 plus 1. So 1 over radical 8 plus 1, 1 over radical 9, which is 1 over 3. Okay? And again, I'm going to show you to go straight to this 1/3 answer using the second definition. So it's going to be f prime of 4. It's the limit when x approaches 4 of f of x, which is this square root of 2x plus 1, minus f of 4, which is 2 times 4 plus 1, over x minus 4. Okay, so this is that. Oops, let me just draw that for a little bit nicer. Okay, radical 2x plus 1 minus square root of, so this is 2 times 4 is 8, plus 1 is 9, so radical 9 is 3, okay, and x minus 4. In order to solve this limit, imagine you're in your AP test and you're given this limit, it's going to multiply by the conjugate. Okay. Similar process. Now again, if you multiply by the conjugate, it is because the middle terms cancel. So you're left with this squared minus this squared. It's going to be 2x plus 1, because it's the square root of squared, then minus 3 squared. Okay. Okay, so now you got 2x plus 1 minus 9 over x minus 4. Now 1 minus 9 is 2x minus 8. Okay. And if we factorize the 2, you get x minus 4 over x minus 4, which is going to be 2. And I didn't get the same thing. Oh, because I forgot this entire term right there. My bad. Back it up. Back it up. Sorry about that, guys. Okay. So the term that I forgot was this bottom term. So limit when x approaches 4. Sometimes it lags, so you'll like draw it weird. Okay. So again, oh my god. Okay. So 2x plus 1 minus 9 over x minus 4 times this entire term, 2x plus 1 plus 3. Okay? And same deal. So you're going to have x approaches 4. Factorize the 2, you get x minus 4 over x minus 4 times radical 2x plus 1 plus 3. Cancel the x minus 4 terms. So you're left with the limit when x approaches 4 of 2 over radical 2x plus 1 plus 3. And now you can go ahead and plug in the limit. So you got 2 over radical 2 times 4 plus 1 plus 3. 2 over radical 9 plus 3. 2 over 3 plus 3. 2 over 6, which of course is equal to 1/3, which is what we had previously. Okay? Right there. Now for the last function, I can find it. It is 1 over x and then a equals 2. So again, we're going to do both methods. It's good to know both. So for f prime of x, get the limit when h approaches 0, f of x plus h minus f of x over h. Let's plug in x plus h on the function. So you get limit when x approaches 0, oops, not x, h. So we substitute x plus h on my function, so it's 1 over x plus h minus 1 over x over h. Okay. Again, the limit when h approaches 0. In order to subtract two fractions, we need a common denominator. So when in doubt, just multiply the denominators. So x over x times 1 over x plus h minus 1 over x times x plus h over x plus h over h. Okay, I'm looking for a common denominator. So on the top you get x, do not distribute the bottom, okay? And then on the top you get x plus h over x times x plus h over h. Now that you have a common denominator, you can write them in one denominator. So you're going to have x minus x plus h over x times x plus h over h. We distribute the negative. You're going to have the limit when h approaches 0 of x minus h over x times x plus h. Now, when you have a fraction over another fraction, you multiply by this reciprocal of the fraction in the bottom. So in this case, 1 over h. X minus x is 0, so you're left with negative h. Now, this h can be put in front. Okay, I'm going to do that because I want to get rid of the h's. So now you're left with this. Negative 1 over x times x plus h. If we plug in 0 for h, you get negative 1 over x times x plus 0, which is negative 1 over x squared. Now it wants us to plug in 2 for x. So again, f prime of x is negative 1 over x squared. F prime of 2 then becomes negative 1 over 2 squared, which is negative 1/4. And now let's find that exact same value using the other formula. So f prime of 2 is the limit when x approaches 2 of f of x minus f of 2 over x minus 2. X approaches 2 of f of x, which is 1 over x, minus f of 2, which is 1/2 over x minus 2. So now, same concept, finding common denominators. So 2 over 2 times 1 over x minus 1/2 times x over x minus 2. So it's 2 over x, 2x minus x over 2x over x minus 2. Now that you have a common denominator, you can put them in the same denominator. So in this case, it's 2 minus x over 2x over x minus 2. And again, x minus 2 is over 1. So you multiply by the reciprocal of the denominator. So you're left with 2 minus x over 2x times 1 over x minus 2. Now before you go and cancel out these two terms, notice that 2 minus x and x minus 2 are not the same thing. But we can force it the same thing by factorizing a negative 1. So you have x minus 2, then 2x times x minus 2. Now you get rid of the x minus 2's, so you have the x approaches 2 of negative 1 over 2x. If you plug in 2 on your limit, you get negative 1 over 4, which is exactly the same thing that we got on the other answer. Okay, that's all for today. If you like the video, please subscribe to Multival. Share with people who are taking the AP test, and let me know what you think in the comments below. Thank you.